Welcome students to instructional video number 2 of the school year, the language of algebra and translating expressions. Now, yes, language of algebra. That means, yes, this is partly a vocab lesson. I know, that immediately makes you very unhappy. But that's okay, because you're going to have to deal with it. We have to learn vocabulary. If you don't know the language, you're not going to be able to do algebra. Simple as that. So the language of algebra and translating expressions. Okay, let's jump right in. Let's go ahead and talk about the definitions of these words. So this is the basic language of algebra that I'm going to need you to know for this first section. Let's start with algebraic versus numerical. Well, algebraic expressions include variables, while numerical ones do not include variables. So as you see over here on the right, we have an algebraic expression. So this is an algebraic expression, 3x squared plus 4x minus 7. And if we wanted to make it just a regular numerical expression, we'd have to lift those variables out. So those old order of operations problems that you've done in the past, those are numerical expressions, while this one here, this is algebraic. Okay, well, including variables, right? So what's a variable? A variable is a letter that is used to represent a number. You can use any one of the 26 letters of the alphabet, but most commonly used are X, Y, and Z, and then also A, B, and C. Of course, again, as I said, you can use any of the 26 letters of the alphabet. Just be careful that it is clear that you're using variables and not some of the letters that kind of can look like numbers, like the letter S, for example. Just be careful with that. Okay, moving on to coefficient. A coefficient is a number that multiplies a variable. It sits in front of the variable. In this case, both 3 and 4 are coefficients, and it's a multiplier. So 4x means 4 times x, or x plus x plus x plus x. Okay, moving on to constant. A constant, a number on its own. The -7 in this expression is a constant, and it can be any value that's a regular old number. It doesn't have to be an integer or a whole number. Moving on to expression. I apologize again, I'm sure there's an editing jump, but I had to slide the whole thing up to be able to type in there. Never mind. Expression is the next one, a mathematical phrase that includes at least one operation. This is an expression right over here, as I've been saying, an algebraic one. What keeps this from being an equation? Why isn't this an equation? Yes, I heard someone say it. It doesn't have an equal sign. No equal sign, not an equation. And finally, the last term on the list for today is term. So finally, term, a single number or variable or a product of numbers and variables. This is also called a monomial. So over here on the right, this has 3 terms. 1, 2, 3. They do have special names. We'll get to that later in the year, but they do have special names: quadratic term, linear term, constant term. If you like vocabulary, you want to start learning that stuff. And as one more quick review, we do have one more little bit of vocabulary hidden by my little rectangle over here. Let's take a look at that. Well, that is exponent, base, and power. So let's just take this and let's actually label instead, or draw some little lines here instead of writing out definitions or typing out definitions for exponent, base, and power. The exponent that we see up in this expression up here is this 2 right here. That 2 is an exponent, so we know that. The base is the x. The x is the base, so it's the value that gets the exponent. Okay, an exponent, remember, is written as a superscript. An exponent tells you how many times to multiply. So what that really means right there is x times x. We multiply x as a factor 2 times. A power would be the entire thing. The x squared is a power. So the 2 is the exponent, the x is the base, the x squared is the power. Excellent. Well, moving on from vocabulary, let's continue. The second half of what we have is translating expressions. So more words, but in this case, words and phrases for the different operations. Now, it is not my suggestion that you copy every single bit of this down. In fact, I think you definitely need the menu of the operations and the words that go with them, but I don't think you need to write out all of these examples in your notes. Again, if you want them there, that's fine, but please do not come back and complain about the amount of time it took to get them on the paper. So we'll go through, and there are examples there. That's for teaching purposes. But really, I think it's best if you just copy the words for the operations and the operation names themselves. Okay, so let's run through these. We've got minus, a number minus 2. Well, that would be x minus 2. The difference between a number and 8. Well, that would be the number minus 8. Difference goes in the order in which it came in the sentence. 2 from a number. Well, if you had 10 and I took 2 from that, we'd have 8. So let's think for a moment. Is that 2 minus or minus 2? 2 from a number. It's minus 2. A number less 3. It sounds a little awkward, but that's x minus 3. 3 less than a number. Well, that's the exact same thing as we just wrote. Again, if you had 3 less than what you had yesterday, say pieces of candy, I have 3 less than I had yesterday. That's subtraction. You're taking away the 3. 2 fewer than a number. Again, 2 fewer. We're taking off 2. A number decreased by 2. And a number take away 2, which is the old-fashioned language we started with in, say, kindergarten, first grade. All right, moving on to addition. First we have plus, so a number plus 2, so that's easy, x plus 2. 3 and a number, so and can mean addition, so 3 and a number. 8 added to a number. Well, let's stop for a second. Here's what's great about all of these all the way down. And we're going to talk about this more when we get to properties. It actually doesn't matter which way we put these. We could have put x plus 2, or I could have put 2 plus x. It really doesn't matter because of something called the commutative property. And we'll learn more about that. We'll practice that, review that some more in coming days, in coming lessons. Okay, so continuing on, 3 greater than a number would definitely be a number plus 3, same idea. 3 more than a number, same thing. Number increased by 2, addition again. The total length, so total can mean addition. And then the old word sum, which is the answer to an addition problem. So the sum of the length and the width, well, that would be L plus W. And of course, we'd be careful with that L. We don't want it to look like a 1. All right, moving on. Multiplication and division. So we have times for multiplication. So 5 times a number. Well, 5 times a number would be 5n or 5x. Okay, we don't need a multiplication sign for that. The product of 3 and a number, 3x. 3 at $1.59. This is actually one of my favorites because we don't always think about this. At is multiplication. If I'm buying 3 at $1.59, I'm buying 3 times $1.59. Okay, so 3 items at $1.59. And what that could also say in the end is maybe each. Double a number. Double a number. So that's 2x. Twice a number. Again, 2x. 3/4 of is a multiplier. So 3/4 of a number would be something like saying 3/4 n. And don't let fractions freak you out. Okay, 3/4 of a number, well, let's do 3/4 of 12. That's the same thing as if I plug that 12 in for n right there. Well, think about it. What's 1/4 of 12? 3. What's 2/4 of 12? 6. 3/4 of 12? 9. So 3/4 of 12 is 9. The quotient of 5 in a number. So now we get back to where order is important here. Now, to go back for a moment, order is kind of important right here. You can't put n5. That's like playing Battleship. Okay, you got to put 5n. But the multiplication can happen in either direction. It could be n times 5, and it could be 5 times n. So the quotient of 5 and a number has to go in the order 5 then the number, and we're going to write that with a fraction bar. Okay, the next one's half of a number. We can do that a couple ways. We can say n over 2, which is what they're going for here because it is division, but you could also say 1/2 n. Those are the same. Those are equivalent, okay? A number goes into 6 twice. A number goes into 6 twice. So 6 divided by a number, and you get the answer 2. Ah, that's what they're going for there. This last one is the price is $8 per 50, and what it had, ooh, whoops, hey, get your writing tool. What it had in the answer key was P equals 8 over 50. I thought that one was a little strange. So just remember that per can absolutely both be division or multiplication. We could say, $1.59 per item. And that would actually be the same thing as this one over here, this 3 at 159, so $1.59 per item would still be, but that would be multiplication then. So per we can use either way. Equals, your equals sign is going to be the word is the same as a phrase, gives, will be, was, is equivalent to, these are all appropriate. Okay, a little more vocabulary on the next page, mostly review. Square and cube roots. So you probably remember this from last year, but we're going to run through them kind of briefly. A perfect square is obtained by multiplying a number by itself. So 1 times 1 would be 1, 2 times 2, 4, 3 times 3, 9, 4 times 4, 16, and so on. A perfect cube is a number that's obtained by raising a number to the third power, so using itself as a factor 3 times. So 1 times 1 times 1, or 1. 2 times 2 times 2, which is 8. 3 times 3 times 3, which is 27. 4 times 4 times 4, which is 64. Now don't be perturbed by the fact that I do that very quickly. I do math for a living. I should be that fast at it. Okay, so when we say squared, we do mean to the second power. So squared is a number with a superscript, 2. So 1 squared, and then if you look up there, 2 squared, 3 squared, and 4 squared. And that's what you're seeing there in the sequence that I gave you under perfect square. Same thing with cubed, except instead of a 2 superscript, it's a 3. So 2 to the third power is 2 cubed. 3 to the third power is 3 cubed. And 4 to the third power is 4 cubed. And so on. When we say square root or cube root, we're undoing that. So if I say the square root of 16 is 4, I use the radical sign, which you see right here, the square root sign, and we're saying what times itself is 16? Well, that's 4. When we do a cube root, you do the same symbol, except you put a 3 out front. So if I instead had cube root of 64, it'd be asking what to the third power. So what times itself again would give you 64, and again that would be 4. Now we'll talk more about these as we go, but I wanted to make sure we introduced them along with one more concept. Absolute value. I shouldn't have said introduced there. I should have said reviewed, because I know you've seen this before, but it's good to have a review. Okay, absolute value. Absolute value is the distance away from 0. So when we say distance, a distance cannot be negative. You can't tell me you live negative 3 miles from Spratley. That's ridiculous. Negative 3? How do you get there? Go down? Do you dig? How do you get there? Do you walk backwards? Maybe that's it. Anyway, a distance can't be negative. A distance can only be positive because it is a quantity that has to be tangible. Okay, negatives are not tangible. So when we say the absolute value of negative 3, we're saying how far is negative 3 from 0? Well, it's 3 units, so the absolute value of negative 3 is 3. Same thing over here. How far is 4 from 0? Absolute value of 4, well, because it's 4 units from 0, the absolute value of 4 is 4. So remember that it doesn't matter which side you're on. If we say 6 or negative 6, or negative 6 or 6, they both have an absolute value of 6, because in order to go from there to 0, it's 6 units. So that should conclude all the vocabulary that you need at this point for the language of algebra, and you're going to be practicing translating some expressions in class tomorrow. So you're going to want to use those notes. You're going to take those notes to class so that you can use the phrases that you had there to help you translate the expressions we'll see in class. Alright guys, thanks for watching. We'll see you in class.